Hello Jefferson. For today's lesson, we are going to be doing the converse of the Pythagorean theorem. I have already started by labeling the next section in my table of contents, converse of the Pythagorean theorem, page 8, and writing down the title on page 8, okay? So far for the Pythagorean theorem, we have been using it to find a missing side length. For today's lesson, we know the lengths of the sides, and the question is it a right triangle? That is our question. Are the triangles right triangles? And the reason why we are asking whether they are right triangles is because the Pythagorean theorem only works for right triangles. So we are going to take a look at the example on page 383. And the side lengths are 3, 4, and 5. And I am just going to apply those side lengths. 3 squared plus 4 squared is equal to 5 squared. 3 times 3 is 9. Plus 4 times 4 is 16, is equal to 5 times 5 is 25. 9 plus 16 is 25. Since 25 is equal to 25, then my answer is yes. These are right triangles. I'm going to do 2 more examples for you, and these 2 examples are really tricky. Because when you are applying the Pythagorean theorem and they give you the side lengths, it's really a common mistake to simply go in order. So I'm going to take a look at question number 11 on page 387. And number 11 says 18.5 feet, 6 feet, and 17.5 feet make a right triangle. Okay, those are my 3 side lengths. Erase that better. Okay, I am going to put this into the Pythagorean theorem, but I noticed that my hypotenuse would be in the incorrect place if I simply plugged in the numbers into the formula. And the reason is the hypotenuse is always the longest length, and in this case, they put the longest length in the first position of the numbers. So what I am going to do is I'm going to reorder these numbers and I'm going to put them from least to greatest. So I'm going to go 6 is the smallest, 17.5, and then 18.5 is the largest. Now I am going to use these numbers. I'm going to plug those into the Pythagorean theorem. I'm going to rewrite the equation. A squared plus b squared is equal to c squared. That is 6 squared plus 17.5 squared is equal to 18.5 squared. 6 squared is 36 plus 17.5 squared is 306.25. 18 and 5/10 squared is 342.25. I'm going to add 36 and 306 and 25 hundredths, and that is 342.25. Since these 2 numbers are equal, yes, it is a right triangle. Okay, my final example is going to be question number 14 on page 387. It is 25, 14, and 23. And in this case, the units were centimeters, but it doesn't matter. The Common Core assessment doesn't ask for units of measure. So what I'm going to do first, like in the previous question, was make sure that my numbers are in order. These numbers are not in order. So I'm going to put them in order. 14 is the smallest, 23 is in the middle, 25 is the largest. Now I am going to insert them into the Pythagorean theorem. A squared plus b squared is equal to c squared. 14 squared plus 23 squared is equal to 25 squared. 14 squared is 196. 23 squared is 529. 25 squared is 650. 196 plus 529 is 725. 25. Is that equal to 650? No, it is not. So this one is not a right triangle. So for the Common Core, your answer is simply yes or no. If they're asking you to explain, you're explaining that if you use the converse of the Pythagorean theorem, it does not make a right triangle. Thank you.